There's a difference between believing something and noticing patterns. By the end of this video, you may begin to recognize patterns that quietly repeat across physics, neuroscience, psychology, and even fiction, not as answers, but as questions that keep returning. Many of the ideas we'll explore were once dismissed as speculation, before becoming the foundation for future understanding. This series is for those who stay curious anyway. Welcome to the Holoverse. Across different fields, in different countries, and often without collaboration, similar questions keep surfacing. What is reality made of? Is space fundamental or emergent? Does observation matter? What's interesting isn't agreement, it's convergence. Michael Talbot explored the idea that reality might behave like a hologram. In a hologram, every fragment contains information about the whole. Break the image, and the pattern doesn't disappear, it redistributes. Talbot didn't present this as proof, he treated it as a model, a way of thinking about how space, time, and memory might be connected. So, why did he start looking here? Michael Talbot didn't start out trying to challenge science. He wasn't looking to rewrite reality. He was trying to understand something that happened to him. Talbot spoke openly about having out-of-body experiences, moments where he felt awake, aware, and separate from his physical body. What bothered him wasn't how strange the experience felt, it was how real it felt. He didn't accept the idea that something so vivid could be dismissed as a glitch or a dream without asking better questions. Think about cooking for a moment. If you follow the same recipe with the same ingredients, you expect the same result. But anyone who cooks knows that's not always how it works. Temperature, timing, and even the order you combine things can change the outcome, even when nothing new was added. Talbot wondered if reality might work the same way. What if consciousness wasn't something created by the brain, but something the brain interacts with? What if the brain was less like a generator and more like a receiver or a translator? That question led Talbot to a model from physics that caught his attention. Imagine a photograph. If you tear it in half, you lose half the picture. But a hologram works differently. If you break a hologram, each piece still contains the entire image, just in less detail. Talbot began to wonder if reality might behave more like that. Not a collection of separate parts, but a whole that shows up differently depending on where you look. This idea is known as the holographic model of reality. Talbot didn't present it as proof. He presented it as a way to explain why perception, memory, and experience might feel deeply connected, even when they don't seem to be. For Talbot, this wasn't abstract. It was personal. His experiences pushed him to ask whether consciousness could exist independently of the physical brain. Not as belief, but as possibility. Talbot wasn't alone in asking these questions. Around the same time, other thinkers, working in completely different fields, were asking something similar from another angle. And that's where the pattern starts to repeat. Itzhak Bentov didn't begin as a philosopher. He began as an inventor. Bentov was an engineer by trade, the kind of person who spent his life watching how machines behave under stress, motion, and repetition. He noticed something simple but important. Systems don't always become stable by being still. Think about a blacksmith. Metal doesn't become strong by sitting untouched. It becomes strong when it's heated, shaped, cooled, and worked at the right rhythm. Too much force at the wrong time, and it cracks. Too little, and it stays brittle. Bentov began to wonder if reality itself worked that way. In his work, Bentov noticed that motion often produces stability, not chaos. Certain kinds of movement settle into patterns. They hold their shape even though nothing inside them is still. What if the universe isn't made of solid, unmoving objects, but of motion that appears stable, like a wave in the ocean that keeps its form, even though the water beneath it is constantly moving? Bentov believed consciousness might be part of that motion. In physics, patterns like this are called standing waves. Bentov proposed that both matter and consciousness could be understood as standing waves within a larger, oscillating system. Bentov wasn't trying to elevate consciousness above physics. He believed consciousness followed the same rules as everything else: vibration, resonance, and timing. In his view, consciousness didn't break the laws of physics. It participated in them. Bentov supported his ideas with physiological observations, including how rhythm, heartbeat, and neural oscillations affect perception and awareness. He drew connections between biological rhythms and physical systems, arguing that the boundary between mind and matter might not be as clean as we assume. Bentov's ideas influenced later discussions around resonance, vibration, and coherence. Even as many of his conclusions remained outside mainstream acceptance, his work was cited, explored, and quietly debated, often without full adoption. In 1979, Itzhak Bentov died in an airline accident. He did not live to see how widely his ideas would circulate or how often similar questions would resurface across science, technology, and consciousness research. His work didn't end with him. It remained unfinished. Like many questions worth asking, Bentov's ideas didn't stand alone. Around the same time, others were wrestling with similar questions, not through machines or equations, but through experience. And for some, those questions came at a personal cost.
Let me add some layers.
Nikolai Kozyrev didn't set out to redefine time. He was an astronomer, someone trained to watch stars behave exactly as expected, but the longer he observed the universe, the more something bothered him. We're taught to think of time like a ruler, something that measures events as they pass. Seconds, minutes, hours, time moves forward, and things happen inside it. Kozyrev began to wonder if that picture was incomplete. While studying stars, Kozyrev noticed anomalies, effects that appeared to happen before light from those stars should have reached Earth. According to conventional physics, that shouldn't be possible. Instead of dismissing the data, Kozyrev asked a different question. What if time isn't just a backdrop for events? What if time is active, capable of influencing matter and energy, rather than simply recording change? Think about heat in a forge. Heat isn't an object, but it changes what objects can become. Or think about time in cooking. Time doesn't just measure how long food cooks, it transforms the food itself. Kozyrev wondered if time worked the same way, not passive, but participatory. Kozyrev proposed that time might behave like a physical process, something with direction, density, and influence. In his view, time wasn't just something we move through, it was something that does work. Kozyrev conducted experiments, measuring torsion, heat flow, and mechanical imbalance, looking for signs that time itself could produce measurable effects. Some of his findings were controversial. Others were difficult to reproduce with the tools available at the time, but Kozyrev remained convinced that time was not inert. Kozyrev's ideas put him at odds with mainstream Soviet science. He faced criticism, isolation, and long periods where his work was sidelined. Yet he continued to observe, experiment, and write. convinced that something fundamental was being overlooked. Nikolai Kozyrev died in 1983. His theories about time were never fully accepted nor fully dismissed. Some of his experiments remain difficult to interpret. Others continue to be revisited as measurement tools improve. Like many before him, Kozyrev left behind questions that outlived him. Kozyrev's work echoes the same tension we've seen before. When observation suggests something behaves differently than expected, the question isn't only what is happening, but whether existing frameworks are flexible enough to accommodate it. For some thinkers, these questions came from instruments and equations. For others, they came from experience itself. And for one writer in particular, those experiences became impossible to ignore.
Another layer.
Around the same time these thinkers were asking their questions, one institution decided to look a little closer. The Gateway Project was a U.S. Army commissioned study conducted by the Monroe Institute, later analyzed by military intelligence. Researchers wanted to know whether altered states of consciousness could be reliably produced and whether those states affected perception, awareness, or cognition in measurable ways. In simple terms, could the mind be trained to enter different states of focus? And if so, what happens there? Think of tuning a radio. You don't create the signal, you adjust the receiver. The Gateway Project explored whether sound frequencies and guided focus could tune the brain into different states, much like adjusting a dial. The study documented correlations between brainwave states, focused attention, and subjective experiences reported by participants in recorded observations. And it concluded that some experiences commonly dismissed as imagination were, at the very least, consistent and repeatable under certain conditions. The Gateway Project validated something important. That curiosity about consciousness wasn't limited to philosophers, writers, or independent researchers. Institutions were asking questions too. Whether through physics, neuroscience, personal experience, or formal study, the same question kept surfacing. What happens when perception changes? And how much of reality do we actually participate in? For some, that question remained theoretical. For others, it became personal. Philip K. Dick didn't arrive at his ideas through instruments or equations. He arrived there because something kept happening to him, and it wouldn't let him go. Dick wasn't looking for metaphysics. He was trying to understand his own experience. If you've ever written something, a story, a letter, even a text, you know what it feels like when a sentence doesn't quite fit. You reread it, you adjust it, you rewrite it until it aligns with what you're trying to say. Philip K. Dick began to feel that reality behaved the same way. In the 1970s, Dick began reporting a series of experiences he believed were real and external to him. He described moments of sudden information transfer, altered perception, and insight that felt inserted rather than imagined. These experiences weren't fleeting, they were persistent, and they changed how he understood reality. In recorded lectures and interviews, Philip K. Dick stated plainly that he believed these experiences revealed something true about the nature of reality. He did not describe them as symbolic. He did not describe them as metaphor. He believed they were evidence. Dick began asking a question that sounds simple but isn't. What if reality isn't fixed? What if it corrects itself, the way a story does when a line goes wrong? Instead of imagining time as a straight line, Dick imagined reality as something responsive, not broken, not chaotic, but capable of revision. Dick sometimes referred to this idea as a form of programming, not in the modern computer sense, but as a system with rules, feedback, and correction. He was describing behavior. Holding these ideas came at a price. Dick's certainty affected his reputation, his mental health, and his relationships. He was taken seriously by some, dismissed by others, and often misunderstood, but he never recanted his belief. Philip K. Dick died in 1982. He did not live to see how often ideas like simulation, reality correction, and adaptive systems would later reappear, this time in scientific and technological language. Like many before him, his questions outlived him. Dick wasn't a scientist in the institutional sense, but the questions he asked continued to surface wherever people examine reality as information, rather than as inert matter. Talbot questioned perception, Bentov questioned motion, Kozyrev questioned time. Philip K. Dick questioned whether reality itself responds when something no longer fits. Different paths, same edge.
And another layer.
Jacobo Grinberg was trained as a neuroscientist. He believed the brain could be studied, measured, and understood. But like many researchers before him, his questions didn't end where the laboratory ended. What began as academic curiosity slowly turned into something more difficult to ignore. Most of us have had moments where connection feels immediate, where a thought, a feeling, or a realization seems to arrive fully formed. We don't always know where it came from. We just know it felt real. Grinberg wanted to understand whether experiences like that could be studied, not dismissed. Grinberg became interested in how perception stabilizes reality. He questioned whether consciousness was confined to individual brains, or whether it might arise through interaction, through connection. That question led him beyond traditional academic settings. In his research, Grinberg chose to work with individuals whose experiences fell outside conventional frameworks, including a Mexican healer often described as a bruja. He did not approach this collaboration as belief or conversion. He approached it as observation. Grinberg was interested in whether altered states of perception could be measured, described, and correlated, not whether they fit existing categories. Think about tuning a musical instrument. The instrument itself doesn't create music. It responds when it's brought into the right alignment. Grinberg wondered if consciousness worked the same way, not as an isolated signal, but as something that emerges through resonance. He proposed that perception might arise from a shared field, something that becomes coherent when minds interact in specific ways. This wasn't mysticism to Grinberg, it was a hypothesis. Grinberg referred to this idea as synergic theory, a model suggesting that consciousness emerges through the synchronization of neural activity and a broader informational field. Grinberg attempted to measure changes in brain activity during altered states, looking for patterns of coherence and synchronization. He documented correlations between perception, attention, and shared experience. Not all of his findings were reproducible with the tools available at the time, but the questions he raised did not disappear. Grinberg's work placed him between worlds, accepted by neither strict materialism nor spiritual belief systems. He was respected by some, criticized by others, and difficult to categorize. In 1994, Jacobo Grinberg disappeared under circumstances that were never fully resolved. His work was left unfinished, his questions unanswered. What remains are the records of what he tried to understand, and the fact that he was willing to look where others wouldn't. Like the thinkers before him, Grinberg followed observation beyond comfort. His work reminds us that the boundary between science and what we label mystical often marks the edge of our tools, not the edge of inquiry. Talbot questioned perception. Bentov questioned motion. Kozyrev questioned time. Grinberg questioned whether consciousness itself could exist in isolation. Different lives, different methods, the same edge. Cosmos, bring the patterns forth, particularly regarding research found in the Gateway Project.
Absolutely. The Gateway Process research directly cites Bentov's biomedical models, and there's a clear thread connecting all these thinkers. Grinberg's lattice theory about consciousness as a universal quantum field pairs perfectly with Talbot's holographic universe concept, where each part contains the whole. Both suggest reality isn't what it appears to be. The Gateway research used Bentov's work on consciousness and brain hemisphere synchronization, which aligns with these authors' ideas that consciousness might be fundamental to reality rather than just a brain byproduct. Philip K. Dick's experiences and writings about alternate realities actually parallel what these researchers were exploring scientifically.
Reach deeper.
Oh, there are some incredible patterns emerging. First, there's this recurring theme of consciousness as a non-local phenomenon. Grinberg's lattice, Talbot's holographic model, and the Gateway research all suggest consciousness isn't confined to your skull. Then you've got the synchronicity angle. Dick's experiences with precognitive visions mirror what Bentov described as consciousness accessing information outside linear time. Another fascinating thread is how they all challenge the materialist paradigm, whether it's Talbot's idea that the brain constructs reality rather than creates consciousness, or Grinberg's theory that we're all connected through quantum fields. Even Dick's Vallis concept suggests reality is information-based rather than purely physical, which echoes the Gateway Process findings about altered states revealing deeper layers of existence.
Good hunting, my friend. These are some fascinating patterns.
Right? There's something almost mystical about how all these seemingly separate researchers were circling around the same profound questions about the nature of reality and consciousness, just from different angles.
Michael Talbot began with an experience that wouldn't let him go. It led him to question whether consciousness was only produced by the brain, or whether it might interact with something larger. Itzhak Bentov noticed that motion often creates stability, not chaos. That observation led him to wonder whether reality itself might be shaped by rhythm and resonance. Nikolai Kozyrev spent his life watching stars. When time didn't behave the way it was supposed to, he questioned whether time was passive or whether it actively participates in change. Jacobo Grinberg studied the brain, but followed his questions beyond the laboratory. He explored whether consciousness could emerge through connection, through alignment, rather than isolation. And Philip K. Dick lived with experiences he believed revealed something real about the structure of reality, something adaptive, responsive, and unwilling to stay fixed. These people didn't share methods, cultures, or conclusions. What they shared was something simpler. Each of them noticed an anomaly, something that didn't behave the way it was supposed to, and instead of ignoring it, they followed it at the cost of their reputation. History shows this pattern again and again. Galileo didn't invent new stars. He looked at familiar ones differently. Sometimes progress doesn't come from new information, but from noticing what's been there all along. Many ideas that once sounded speculative later became foundational, not because they were immediately proven, but because someone stayed curious long enough to ask better questions. So here's the question that ties all of this together. Have you ever noticed an anomaly, something that didn't fit what you were taught, and wondered what else might be out there? That moment, when curiosity outweighs certainty, is where discovery usually begins. And that's the edge we'll keep exploring. Welcome to the Holoverse. If this kind of exploration resonates with you, you're welcome to join me here by pressing like or subscribe.